Hey everyone, this is Stone. Wanted to give a presentation real quick to assist drafters in the permitting department on some plat map reading skill sets, as well as utilization of field work that was done by our fielders, and how to analyze and correctly think about how to approach strategically and be as efficient as possible when you're creating your subject area for your permit. So we're going to dive into this scenario and dissect it up a little bit. All right, so here we go. So let's say that you have a permit, small little thing that you need to do. It's in this red ellipse area. And that's your area of interest. So you need to correctly and accurately represent the right-of-way and center lines and PUEs. Now, by now you should have already gone through the plat reading map, so we're going to talk about that. Also, you will need to get a better understanding, or already have the understanding of what content are you utilizing to import line work. Where does it come from, and what's its accuracy? So right out of the gate, this area right here that we're talking about, when QGIS develops a DXF and you import it in to start your process, realize that it's garbage. And you're going to use some of the garbage to help, but you're going to correct some of that garbage as well. And one of the things that I'm going to make mention about is that you see where it says you need to correctly and accurately represent the right-of-way, center lines, and PUEs. That is true, but I just want you to know that in the QGIS DXF file, when you import that, it doesn't import the center lines and it doesn't import the PUEs. That's something that you have to create and fix the rights-of-ways that were coming in from the QGIS. So if you have the sloppy GIS line work, you can use it for graphical representation only. So what is your first step in your process? Do you start with recreating the subdivision line work from the PLSS building into your subject area? And again, in this video, I'm with the assumption that you by now are learning or already know about the PLSS and how we leverage that, because the PLSS does come in survey grade accuracy from the QGIS DXF file when you import it. That information is in fact correct. But do you go to that length right out of the gate and make an assumption? To recalculate everything from the PLSS? So if so, if you were to do that, would you also create the right-of-ways and PUEs at the same time? I'm just going to go, God, I would hope not. That would be a big waste of time. So please do not, when you're going back to the PLSS to create something, don't assume that you've got to do all of the rights-of-ways and PUEs for the entire area that you're calculating for the entire subdivision. Only focus on your subject area, which means drill down to the center line that is necessary for your subject permit. And then from the center line in that small little area, then you can correct up the rights-of-way lines and create the PUEs. Hope that makes sense. All right, so here we go. I wanted to point out a couple things here. Obviously you got the ellipse, that's where your permit is. What's this other ellipse doing? So if you have completed the Plat Reading 101 guide, what is the first thing you should do? You got to orient yourself. Where is north? Well, here's a tip. On this graphics here, you can't see a north arrow. It is officially on the drawing and on the actual original PDF, but it's not visual to you, is it? So that's fine. Look at the bearings. It gives it away where the north arrow is. So look at the bearings, then you can make a determination. North is from right of the image to the left of the image. And if you look at this bearing right here, north 21 or 29, 21, 0, 5 or 3, I can't really read, west, that means that north is, if you can see my cursor, going strictly like this. So that's a little hint. All right, so continuing on, let's see here. There's the north arrow. There you go. Next, you'll need to find out if our fielders have completed the field survey and the drawing that comes from that, which is now a DXF now these days, and its process is ready for you. So you would want to determine if that's the case. If that survey fielder drawing is completed, You don't want to go spending and wasting a bunch of time on the PLSS and bringing it all in, wasting all that time, because the surveyors might have found, just like you see here, points 1 and 2. So let's assume it is. Now you quickly assess in the survey collection and determine that our surveyors, fielders, collected 2 street monuments, points 1 and 2. All right, so since the fielders found 2 centerline monuments, you do not need to recreate the subdivision line work off to the la space in CAD. I'm going to just diverge a little bit here. What does la space means? It means that if you're going to be dealing with a PDF of a plat of a subdivision or a survey, it's not geospatial. So you would go away from your subject area in model space and you would recreate using map list and the PLSS monuments that are listed on the plat to recreate your center line. Then you would shift and rotate it in. But that's not what this is all about here in this video. But measure the distance between the 2 found monuments in your CAD. All right, so when you do that, notice that you've got 532.00 here. I'm just going to keep going here. You won't match exactly the distance shown on the plat. And I emphasize, you rarely will match exact of what a plat says. We survey things in the field to a plus or minus of 1/10 of a foot of accuracy. Things that are actually placed in the field are also not according to the record. So it's not your decision, or you don't have any authority to say, well, I'm going to reject what the surveyors did. Let's say that I've got a distance of 532.55. Why would you reject it? You shouldn't. And you don't have the authority to do that. It's a fixed monument. We accept it. So just continuing on here, the record plat may say 532 and you measure 532.52. Who cares? Your subject site is nearest to point 2, right? Here we are. So using the found monuments, draw your correct center line between the 2 monuments, between 1 and 2. Draw your line. Now, just as notice the bearings. I would have drawn from 2 to 1, but you can go 1 to 2. Depending on your permit, you know that you might have to reverse some polylines anyway to get the right orientation to happen, correct? So that's another scenario. Now, you already know that the QGIS DXF file imported in rights-of-ways, and those rights-of-way lines in your permit area have to be erased and recreated correctly, which are along Palm right here, and Bluebell right here. Now, I'm just going to make another statement here. When you erase those, and you create the new center line and you offset the center lines to create your new right-of-way, you've got to do your map cleanup, which means that you got to trim or extend those parcel lines to your newly created right-of-way. Just a note. All right, moving on. So I've got some ellipses here now that's showing up, and I'm going to point those out for particular interest. You've got to learn how to analyze your plat. So that you can kind of back yourself in about your strategy. How are you going to get this created? What's going to help you? So now you have some challenges on getting those curves built in correctly at the intersection of Palm and Bluebell, right? And I'm pointing to it in the area of your ellipse. You've got 1, 2, 3 curve data, and you would refer to your curve table on the plat for that. And it's not in this video. We're not going to go that deep dive. But you're going to try to figure out how are you going to build it. How are you going to build it off of points 1 and 2? What information do you have that you can do it? You can't do it from over here at point number 1 because you don't have a good starting point. You can't get to C49. You can't get to this point right here and go that direction. So that's things that you got to quickly analyze. How are you going to get this side of your right-of-way fixed? And how are you going to get this side of your right-of-way fixed? So, are you going to slop in the QGIS DXF lines and curves? Meaning that would you accept the right-of-ways? We already went over that, so it would be a shame on you if you do, and a violation of our core values, right? Details. We are all about details and passionate to make sure that it's correct. So you don't accept the QGIS DXF lines and curves along the rights-of-ways in your subject area. That's why I say better not. You have to think like a surveyor. Since point 2 is not a radius point for curve 51, which this is curve point 2 and this is curve 51, obviously just by the naked eye you can look at it and go, where would the radius point be for this curve? It would be somewhere out in this area, right? It's just not even close to point number 2. It was never intended to be the radius, just so that you know that. So you have to study the various center lines and their bearings on the Plat itself a little bit further. And so is Larkspur, this is Larkspur, and this is why this ellipse is this, and then ellipse is there on Palm. Is Larkspur perpendicular to Palm? Yes. Now, I'm helping you out here to a degree. I'm making it so simple, so idiot-proof, that you can get the results without being a surveyor. So use ChatGPT, and this is what you would put into it. What is the angle between this, north 0, 1, 11, 13 east, and north 88, 48, 47 west, and put it in exactly like this? It's going to come up and yield 90 degrees. Now, by a naked eye, you should get trained eventually to even look at and do a logical deduction at these two and go, yeah, that's 90. I know I can. I know surveyors in general can. I can go somewhere else and look at it and say, nope, that's not perpendicular. But that's just, you know, getting experience. But to build your own confidence so that you do your checks, use ChatGPT to get you the answers. So anything that's 90 degrees to any other line like this is 90 degrees perpendicular. That's what that is. This Larkspur line, center line, is perpendicular to Palm Drive. And that's easy enough to create. So now calculate the intersection down south from point 1. Now remember I said south is, you know, where's the north? Well, it's right there. And you're going to go from point 1 south, the distance of 266.00 feet. Now you can do that by putting a circle here and like that, and then wherever it intersects, that's your point. Then you would draw a line perpendicular up that way, 146, I can't read that, but you get my point. So that's how you would establish the center line of Larkspur. And then once you do that, you would probably offset the center line of Larkspur both sides, even though it's not in your subject area, but it may show up in your paper space. So, you know, throw it off and create both sides, the south side of the right-of-way of Larkspur and the north side. All right. So from here, you can offset to the center. I just repeated that. And offset Palm to 25 feet to the east and the west. That would get you this line and this line, right? And it would also get you this line, so that you could do the rest of, you know, more information later. But you're getting things accomplished. Now, is Bluebell perpendicular to Palm? Look at the bearing, 892103, northwest, and this was northwest. This was perpendicular to it. Obviously, it's not. The answer is no. You should logical deduction. No. Again, use ChatGPT, or you could use MapRoutine. Draw in the two record information and then do a dim. But when I say draw in the record information, you can draw that off to the side, because this along Palm Drive, that bearing is not what you're going to get if you measure between point 1 and 2. That's the critical part about what you're doing. You're not necessarily always using record information. You're using stuff that's measured, and then you're rotating things to the, you know, from the record to your measured. So that would have created the center line of Bluebell if you would have rotated it the angle that it was supposed to be. So you would take this, rotate it from there, you know, there you go. Now it's in, right? So assuming you have built in from the two found centerline monuments the center line for both Palm and Bluebell, by using the record angle of 8927.43 to turn from Palm to Bell. By the way, when you're in ChatGPT, you want to make sure that your results are yielded in degrees, minutes, and seconds. If it just gives it to you in degrees, you will mess up. So, to turn from Palm down here, and up Bluebell. Apparently I've got a spelling error here. This should have been Bluebell. Your next puzzle is to determine how to build the south right-of-way of Bluebell. South right-of-way, that's this yellow big long line. You're going to need the north right-of-way too, right? But this is a little bit more easier. It just is. So how to build the south right-of-way of Bluebell and the west right-of-way of Palm. So the west right-of-way of Palm. That's partial, you know, that's what we're getting down into. How are you going to do that? So study your options. What components are needed to get this task included? including the curves near lots 142 through 145. Here's 142 through 145. That's all curves in this area. And I'm gonna say again, pay attention to details as we discuss this. There are potential errors that people do because they're not paying attention to details, and it's easy to screw up. So it's important that your focus is right on target. So 58683 over there along Bluebell came up and it just popped up. So you'll need to go to the intersection of Rosa Drive. You got to get to this Rosa Drive and Bluebell, and you need to like I said, turn the angle at Bluebell, go up the distance of 586.83. That gets you to this point. What's the first thing that you see up here that should be distracting to you? You got a closed solid circle, and then you got a center line that is, well, if we were correctly, it would be south 10 feet. So our center line is south 10 feet from the PC of Rosa. Notice also along Rosa you've got 190.01 and then 200.01. That's because the 200.01 goes from the monument of the PC to McClintock. The 190.01 goes from the center line of Bluebell at the intersection of Rosa over to McClintock. So, just paying attention here. You will need to go to the intersection, that distance, then create the center line over to McClintock of 190.01. Calc the angle just like you did the others, because it won't be the record bearing. So you're not just going to fly, once you get to this, you're not going to just fly over north 003857 east or southwest if you were to do the back bearing. In that case it would be. So you just can't plug that in. Calc the angle between the record, and then you would do it in correctly by putting the proper angle in there. So now from the center line you just created, offset to the west, which is down this down to this, 30 feet to create the west right-of-way line of Rosa. I don't think we need the north line, or we don't have any of that information right now anyway. But anyway, it gets this line then. So if you were to offset that line, it would have a line that would go out here like this. That's fine. And then if you have not done so, I think we did already, offset the center line of Bluebell 25 feet to the north and south. That would be, once you got this created, you would offset that 25 feet and this 25 feet, and you would have this big long line up here. That's fine. And you'd have some danglers, right, that you got to do trim and extends or whatever. So what this is saying is that since you now have the west right-of-way line of Rosa and the south right-of-way line of Bluebell, this line and this line, you don't yet have this chamfer right here of 2121. Now what you can do though is use the chamfer command and put the 2121 in. And I'm giving you a hint here too on how to do this, and because when you put in chamfer, you can't just put in 2121, can you? You got to put in what the legs are. So use ChatGPT again and put in what are the legs of a triangle if the hypotenuse is 2121, because really that's what this is up here is a little triangle. If you were to extend that line out and extend this line out and trim it to where it's meeting and intersecting, then you would go back 15 feet and back 15 feet, and it would give you 2121. And that's par for the course for the rest of those going throughout this entire plat anyway. So it gives you that distance with chamfer. You can figure out how to create that part now. So now I add up all the lot dimensions. So the way I do it, I look at what's the commonalities. I go 54, 54, 54, 54, 54, 54, 54. So that's 1, 2, 3, 4, 5, 6, 7. 7 times 54 plus 44 plus 11.81. This is where people mess up a lot, right there. They forget that part, they're not paying attention to details. So be very careful. That is a tangent line coming right to this point right there, not the property line. Okay, now the 54, 54, that's from property line to property line. That's why. So you would add all that up, you should get 433.81, and from here you simply use the map LSP command to create the rest of the curves through and over to the northeast corner. This would be the northeast corner. And in this case, do you see any tangent distance between it happens to be that the northeast corner of lot 142 is also the point of tangent. This is the point of tangent. This is a tangent line. So just as a matter of language, I'm coming down a tangent line, I'm going to have a left curve at 11.81. It begins a left curve, and it goes a PC to a PRC because the direction of this curve is going this direction. The direction of this curve is going this direction. It's reversing the curve, and it's going to here. Then it's going to PRC again, point a reverse curve, and go over to the PT and out into the tangent. That's the proper language. So anyway, you want to tidy up all your line work and trim, extend, chamfers, and all those kinds of things. And by the time that you get all the way down to here, you should have matched the offset line of the 25 foot perfectly. All right, so there you go. You got a good methodology. I hope this helps out.